Okay, so let's see what problems you have to do the homework, first of all. Could turn on it? All right. Okay, so I'll just take the homework questions now. Any questions that you needed to have sorted out? Anything? 14? Let me see it. Okay, so we're looking at exercise 52, number 14. Right? You're looking at exercise 52, number 14. Afternoon. Okay. So that one said, a firm buys office machinery at a cost of $15,000. It is decided to calculate the depreciation each year as 15% of the book value at the beginning of the year. Calculate the book value at the end of 5 years. The book value at the end of 5 years. Sure. Now, depreciation is actually like the reversal or the reverse of compound interest. Whereas compound interest, you keep adding, right, on top of an initial amount. Right. In depreciation, you actually keep subtracting from a reducing balance at all times. So if you recall, the compounding equation was the amount accruing A was equal to P principal into 1 plus R over 100 to the power of N or T, right? Let's put what the textbook has N, right? It means the number of years, right? So you put N here. That would be the compound interest formula. But what we're interested in is the depreciation formula, which is similar. Depreciation formula says that A, which would be the depreciated value at any point in time, would be P, which was the initial value that you started off at, into 1, instead of plus, it wouldn't be plus, it'll be minus R over 100 to the power of N. Okay? So there's a slight difference in the depreciation formula. So how would we apply this formula in our situation? Because what they're asking us is, in this question, calculate the book value at the end of 5 years, which means this A here is the book value, is the value that it will have if it's depreciated at the rate of R, starting off with an initial value of P. So let us put that into the equation. A, which would be the book value that they're talking about, would be equal to P, $15,000 would be P, into 1 minus the rate of depreciation, which is depreciating at a rate of 15%, which means it's dropping by 15% each year, over 100 to the power of N. N being the number of years you're looking at the depreciation over. In this case, the number of years depreciation is 5 years. Okay? That clear so far? All right. So this would be equal to 15,000 into 1 minus 15 divided by 100 is 0.15 to the power 5. This should be equal to 15,000. 1 minus 0.15 is 0.85 to the power 5. Okay? So this is what your calculation would look like. So now, you have to put that into your calculator and evaluate it. So you go to your calculator, and what is it that you'll be typing in? What you'll be putting into that calculator to work it out? That's the question. So I'll put that in black on the side here. What will be? You type in 15,000, right? Multiply. You press the multiply button. Then you type in 0.85. Then you type in the button that is marked y to the power of x. Right? We're using the Sharp DAL calculator, so this is what you'll be typing in. And then you'll press in the number 5. Right? So this here would give you the answer to that particular working that you need to evaluate. So what we do next, we work that on the calculator and we'll see what we get. 15,000 multiplied by 0.85 raised to the power, which means put y to the power of x, 5, and we get 6,655.5, and you have to round it off to the nearest cent, so that'll be 8. So your answer in this case should be $6,655.58. Okay? Any questions on that? Anything you want sorted out or cleared up there? Yeah. Why change it to minus? Right. The first equation is the equation for compound interest. In compound interest, you have an initial amount, which is called P, and every year you add on to that, right? At a rate, a particular rate. In this question is a depreciation question, and depreciation is the opposite of compound interest. In depreciation, you keep dropping at a constant rate on your starting value. Good? So let's say you have bought a vehicle. Every year that vehicle will depreciate by a certain amount. And in the next year, each successive year, it will keep dropping from that new value. And therefore, we use this equation for depreciation. So we could even write it up here so that you remember. This one here is for depreciation. Okay? So that one is for depreciation. Okay, so the first one is compound interest, and the second one is depreciation. Any other questions on it? Good, that's okay? All right. Okay, next question. Anything else you all have that you want sorted out? That's it. Any other question you all want sorted out? No? Okay. I'll get it for you during the class. Okay? Thanks. Yeah. Okay. Okay, so we're going ahead with another example in the percentage area. and I'll call it out for you now. A businessman bought a stove. A businessman bought a stove for $1,209. A businessman bought a stove for $1,209. A. Calculate the selling price of the stove. A. Calculate the selling price of the stove if he made a profit of 11%. Calculate the selling price of the stove if he made a profit of 11%. As A. B. The stove is damaged in transporting it to the customer. The stove is damaged in transporting it to the customer. Full stop. Find the selling price of the stove. Find the selling price of the stove if he incurred a loss of 8% on the cost price. So B reads, the stove is damaged in transporting it to the customer. Full stop. Find the selling price of the stove. Find the selling price of the stove if he incurred a loss of 8% on the cost price. If he incurred a loss of 8% on the cost price. Full stop. State your answers correct to the nearest cent. State your answers correct to the nearest cent. Okay, so look at it for a moment and see if you have any ideas as to how you could work these two questions out. And then we'll start it up. Let's read it over and see what you come up with. Okay, so if you had gotten for the first answer $1,341.99, you got it correct. Right? If you didn't, let's see how you're supposed to get that. And then we'll look at the other part. Now, in this question, they told us that the profit, which we'll call P, is equal to 11%. Right? 11%. But 11% of what? Is always, unless otherwise stated, as a percentage of the cost price. So it'll be 11% of the cost price. Good? 11% of the cost price. So in mathematical terms, the profit here will be 11%, means 11 over 100, right? Multiplied by the cost price. And what was the cost price in this case? It was $1,209. Okay? So that's, you just take the words, write it down, and then you convert it to the maths. And when you evaluate this, remember, of course, that you're trying to get everything to the nearest cent. You'll find that you get an answer here of $132.99. Okay? $132.99. But they didn't want to know the profit. They question asked you to find the selling price. So you have to know that in order to come up with your selling price, what you do is whatever you pay for it, which is your cost price, you're going to add on the profit that you want to make, and you'll get your selling price, right? Whatever you paid for it, which is your cost price, plus your profit gives you what you're going to sell it for, which is your selling price. So all we have to do is take the cost price, which was $12.09, and we add to that the profit that we got, $132.99, and that would give us what we're interested in. That would give us a figure of 1341.99. Okay, 1341.99. Okay, so that was for part A. What about part B now? In part B, you said that they had a loss instead of a profit. So if you write down what they said the loss was equal to 8%. But again, you always assume the loss and the profit is a percentage of the cost price. So you say 8% of the cost price. Okay? So this would translate to 8 over 100 multiplied by the same 1209. Okay? By the same 1209. And that would work out to be, when you work that out, you should get $96.72. $96.72 is what you should get there. But now, you want to get the selling price. How do you come up with your selling price if you made a loss? Well, whatever your cost price is, you take away your loss from it, and you'll end up with the selling price that you sold it for. So cost price minus your loss is equal to your selling price. How do you get that? Your cost price again was $12.09. You're minusing your loss from it, which is $96.72. Okay, and you're going to get what your loss was, and you should come up with a figure of 1112.28. 1112.28. Okay, you have any questions on that? Now, these equations, I didn't give it to you in this form. I gave you the equations in another form. What you had to manipulate the equation to come up with this if you didn't know this off bat. So if you went back, you'd see that your first equation was profit is selling price minus cost price. From that, you could get this, and I gave you an equation, loss equal to cost price minus selling price. From that equation, you could get this one. Okay? But also, once you understand how you come up with a selling price, it's easy to see your selling price is either your cost price plus your profit, or in the case of a loss, your selling price would be your cost price minus your loss. Okay? Now, what I want you to observe in these questions so far, what we had to find was selling price. And selling price is a rather straightforward type of question. When they ask you to find the cost price is when it becomes very tricky. And that's where most students have problems and they make errors and so on in that case. All right, so we have to be careful with that. And we're going to learn how to deal with that in the next section, where we're going to introduce something called percentage change. Okay, so the next thing we're going to be taking notes on is something called percentage change. And you could head up that, percentage change. So percentage change is what we're looking at now. Okay, so you write, consider a quantity initially as 100%. Consider a quantity initially as 100%. Initially as 100%. Full stop. If a quantity is increased, or decreased by a small percentage, if a quantity is increased or decreased by a small percentage, say X% of itself, comma, say X% of itself, comma, then the new percentage is, then the new percentage is open brackets 100 plus or minus X percent. Then the new percentage is 100 plus or minus X percent. The most, full stop, the most general equation for this is, final amount, which we will call F, will be equal to 100 plus or minus X percent of the initial, or multiplied by the initial amount. Initial amount I. right? Initial amount I. We use the plus x. We use the plus x when there is a percentage increase. We use the plus x when there is a percentage increase. And the minus x when there is a percentage decrease. And the minus x when there is a percentage decrease. That is, f therefore will be equal to 100 plus or minus x percent times I. 100 plus or minus x percent times I. Okay, so let us look at some examples. If we're looking at profit and loss, let's look at a profit. For a profit, of x percent, for a profit of x percent, what will be our final price? Would it be cost price or selling price? When you're dealing with profit and loss, what will be the final price that either you sell it for or they pay for it? What will it be called? Selling price. So the final price in that case is the selling price. And that will be equal to 100 plus or minus, we're not sure which one it is yet, so plus x percent of the initial price. And the initial price will therefore be the cost price. Now, how you reason out this is, whatever your cost price was, that's the initial price, that represents 100%. Now, in order to get your selling price, you're going to increase the cost price if you have a profit of x percent. So if you want to increase the cost price to get your selling price, then this will be plus. Okay? So if you have a profit of x percent, the equation that we're looking at is selling price is equal to 100 plus x percent times the cost price. If you had, instead of a profit, you had a loss of x percent, then your selling price now will be 100, what should I put here now? Minus x percent of the cost price. Why is that? Because your cost price, which was initially 100%, is going to be reduced by whatever the loss is to get your selling price. Okay? Let's look at another one. Let's look at a discount. For discount of x percent, right, you go into a store, right, and they tell you you're going to get a discount. What happens? The first price that you have here is your initial selling price. So I'll just write initial SB. That's the first price that they had. Good? But what you are going to pay here is the discounted selling price. So let's put here discounted selling price. Discounted selling price. So I'll just call that D. Right? So your discounted selling price in relation to initial selling price, will it be less or more? It's going to be less, right? That's your final price. So therefore, if it's going to be less, then this has to be a reduction. So it has to be minus X% times your initial selling price. Okay, so for your discount of X%, your discounted selling price is 100 minus X% of your initial selling price. Okay? The next one we're looking at is VAT. For a VAT charge, looking for a VAT charge of X%, for a VAT charge of X%, what are we looking at? For a VAT charge of X%, let us look at your final price. The final price, which is what you're going to pay, is that your VAT inclusive price or VAT exclusive price? What you pay? VAT inclusive, right? So therefore, I should put as my final price, which is what this area here is, my VAT inclusive price will be here on this side. And my initial price here, that will be my VAT what? Exclusive, because we don't pay the VAT exclusive. That's what you see first, and then they add up the VAT and you pay your VAT inclusive. So, if your VAT exclusive price, which is initial, represented 100, your VAT exclusive price is 100, your VAT inclusive price, will it be more or less than the VAT exclusive? VAT inclusive, more or less? More, because you have to add the VAT, not so? So therefore, because it's more, you have to add your X%. So you always look at your final price in relation to your initial price. If your initial price is going up to get your final price, then you have to add the percentage. If your initial price is falling, as in the case of a discount, you have to minus the percentage. Okay? That's what this is about. And you'll see some examples with it coming up now and how useful it could be. Alright, the example I'm going to call, let me give you 2 minutes to finish right out that. Okay, first example of this here is a businessman sold a fridge. A businessman sold a fridge for $2,745. A businessman sold a fridge for $2,745. $2,745 and made a profit of 15%. And made a profit of 15%. On the cost price. And made a profit of 15% on the cost price. A. Calculate the cost price. A. Calculate the cost price of the fridge. Calculate the cost price of the fridge to the businessman. B. A businesswoman sold a fridge for $2,149, incurring a loss. A businesswoman sold a fridge for $2,149, incurring a loss of 12% on the cost price. Full stop. Determine the cost price. Determine the cost price of the refrigerator to the businesswoman. Determine the cost price of the refrigerator to the businesswoman. Full stop. Determine the cost price of the refrigerator to the businesswoman. Full stop. State your answer to the nearest cent. State your answer to the nearest cent. State your answer to the nearest cent. Now my information to you is that notice in this question as compared to what we were doing initially, we are being asked to find the cost price. We are not being asked to find the selling price. Okay? And whenever you have to find the cost price, there's where it becomes a little tricky. Okay? So I'm going to give you 2 minutes to look at the question, right? And see what ideas you have that you would approach this with. Okay? And then we would see how we would do it using these formulae that we learned above. So take a quick look at it and see what you come up with. Okay. Now as I told you, this one is the one that is a little trickier than the others. Now this question is one that requires you to find the cost price. Now the cost price is just one example of a situation where you have to find what we call the initial price I in the equation, the general equation that I gave you. If you recall, the general equation that I gave you just now was final price F is equal to 100 plus or minus X% of the initial price, of the initial amount. Now in our situation, your final price is your selling price. Your initial price is always your cost price. And depending on if it's a profit or loss, you'd have to add or subtract it. Okay? In this case, in the first question, calculate the cost price of the fridge to the businesswoman if she made a profit of 15%, right? In that case. So this would have to be plus the 15%. Plus the 15%. Okay? That's how the equation would read. Because remember, it'll be plus. If it's a profit, you add, and if it's a loss, you subtract. So your selling price, which is what they had, 2745. That's your selling price. That would be equal to 100 plus 15% of your cost price. 100 plus 15 is 115% of your cost price. And in this case, your cost price was unknown. That is unknown. You don't know what that is. That's what you have to figure out. So now, 2745 therefore is equal to 115% means 115 over 100 to convert it to a percentage, 115% times your cost price. Now 115 over 100 is 1.15 times your cost price is equal to 2745. And you learn that if I want to get what my cost price is on this side, I'd have to divide the right hand side by 1.15, and therefore I'd have to divide the left hand side by 1.15. And when you do that division, what do you get? Anybody checked it? Divide 2745 by 1.15. Right, you get 2386 2386.96. Now, you all got different answers. Nobody got this one, right? So let us see if this makes sense using our old techniques. Let us check it back, right? If we say that 15% is your profit, somebody find 15% of 2386 and the answer you get, add it now back to your cost price, which is 2386, and see if you get the selling price of 2745. That is the ultimate test to see if what we did is correct, not so? So check it back for yourself and see now. If this is your cost price, which is what I'm saying is the answer, nobody has got it to be this. If this is your cost price, find 15% of that and add it back to this, 2386.96, and you should get 2745. Check it and see now if you're getting that. Are you getting it? Right, so it means that what we did is correct on the board. All right, so that's why I started off by telling you, anytime you have to find the cost price or any other initial price which goes on this side of the equation, when you use traditional methods, all the methods that you would think of, it tends to give you wrong answers because you notice nobody came up with this. Everybody came up with the main answer was the 2333.5, right? Whereas this is the correct answer for that particular question. So check it and see for yourself. Make sure you understand what we did. We're going to do a couple more examples with it just now. As a matter of fact, once you're okay with this, go ahead and try and see if you could apply it to part B now. Try and see if you could use this equation, use this as a pattern that we have on the board here, and try to see if you could work out part B now using a similar strategy. It's just that in that case, she made a loss, right? And you know for the loss, instead of this being a plus, it'll have to be a minus. So check it out and see what you come up with. All right, so looking around, I saw that quite a few people getting the hang of it. I saw that they had some right answers and right working, which is good. All right, so very quickly, if we had to write down the equation, right, this was part A that we did initially. So if we're looking at part B, in part B, the equation that you should have written down, your selling price, in this case, was $2,149, right? That would be equal to 100. In this case, it's a loss. So, you know, it wouldn't be plus, it would be minus. And the loss in this case was 12%. So the equation will be 2149 is equal to 100 minus 12% times whatever the cost price is. Okay, times whatever the cost price is. So now, very quickly, it'll be 2149 is equal to 100 minus 12 is 88. And 88 as a percent will be 88 over 100 multiplied by your cost price. So now, 2149 would be equal to 88 over 100 is 0.88. Okay? And then if you divide both sides by 0.88 to get your cost price on your right-hand side, you'd get 2149 over 0.88. Okay? And that gives you a cost price. And when you work that out, you'll get the answer that I told you about, which is $2,442 and 5 cents. 2442.05. Okay, I hope you're all okay with that. Example 2, write down example 2. In a sale, a CD player was sold for $2,071. $2,071 after a discount of 5% was given. After a discount of 5% was given. Calculate the marked up price of the CD player. Not the marked up, sorry. Calculate the marked price of the CD player. The marked price of the CD player. Okay? So that will read, in a sale, a CD player was sold for $2,071 after a discount of 5% was given. Calculate the marked price of the CD player. Now, if you look at marked price in isolation, you might know what that is. What's the marked price? Would it be the price before the discount or after the discount? If you looked at it by itself. But if you're right, from the reading at the start, you know that it was sold for $2,071 after a discount was given. So the marked price would have to be the price before the discount was given, right? Therefore, if it's the price before the discount was given, that is what is known as the initial price. And we know now that anytime we have to find the initial price is a tricky situation, and you have to come and use this equation to help you solve it accurately. If you go back to any of the older methods, you tend to find you get a wrong answer. Okay? So anytime, the secret is, anytime you realize you have to find an initial price, then we're going to use this equation that we have on the board now. You could also use this equation to find the final price, but we're very accustomed to doing our methods there, so it's not mandatory. But anytime you have to find the initial price, you must use that equation. So try it out quickly using this equation here on the board and see if you could get what was the marked price of the CD player. Right, so for this one, we have the equation final price is equal to, open brackets, 100 plus or minus X% of the initial price. If you're increasing the initial price to get the final price, you're going to add the percentage increase. And if you have to decrease it, the initial amount to get the final amount, you have to subtract it. Now in this case, you had the CD player being sold for $2,071 after a discount of 5% was given. So your final price would be $2,071, right? Because that's after the discount was given. Therefore, it means that the initial price will be your marked price, which you'll call MP. Okay? And what you have to ask yourself is, to get from the marked price to the final discounted price, do I have to add the 5% or do I have to subtract the 5%? And the answer is that I have to subtract the 5% because it's a discount. Whatever it was marked, I had to subtract the 5% to get the final price that I'm going to pay for it, which is the $2,071. I didn't have to add the 5%, I have to subtract it. It's a discount. So that's how you get that final equation, and therefore you have $2,071 is equal to 100 minus 5%. Now 100 minus 5 is 95%. And percent means divide by 100. Okay? So that basically becomes 2071 is equal to 0.95 multiplied by a marked price. So therefore, to get your marked price, all you have to do is take the 2071 and divide it by 0.95, and you're going to end up with your marked price. Okay, and that works out to be the figure that we spoke about, which is $2,180. $2,180. Okay? The final example in this sequence here would be, if I could get it. Example 3. Okay, so I'm going to call it out for you now. Example 3. The price of a mower inclusive of 15% VAT, the price of a mower inclusive of 15% VAT is $1,050. Is $1,050. Full stop. Calculate the mark price. Calculate the mark price of the lawnmower. Calculate the marked price of the lawnmower exclusive of VAT. Exclusive of VAT. VAT meaning value added tax. Correct to the nearest cent. Calculate the marked price of the lawnmower exclusive of VAT, correct to the nearest cent. Okay? So I'll leave you to work on that one. I wouldn't give you any hints. You go ahead and see what you come up with now. Okay, so this one should have been fairly straightforward. Right? In this case, your final price would be a VAT inclusive price. And your initial price will be a VAT exclusive price. Because initially, the price has its VAT exclusive price marked on it. And then when you go to pay, you must pay the VAT inclusive price. And we know that if the VAT exclusive price is 100%, then to get the VAT inclusive price, we have to add the VAT onto that 100%. So we'd have to add the 15% VAT onto the VAT exclusive price, which is represented by the 100% in the brackets. And the equation would be VAT inclusive price is equal to 100 plus 15% times the VAT exclusive price. So we just work on this, putting in our figures. The VAT inclusive price was the $1,050. 100 plus 15 is 115%. 115% means 115 over 100 times the VAT exclusive price, which is the price we're interested in. Again, it's an example of where we have to find the initial price and where this equation would help us quite a bit. So now, to get the final answer, which is the VAT exclusive price, we have to divide by whatever 115 over 100 is. And 115 over 100 is 1.15. So I'm going to divide by 1.15 on both sides, and I'm going to end up with this equation here. 1,050 over 1.15 will be equal to the VAT exclusive price. Okay? And when you work that out, you should find that you will get a figure of $913.04. 913.04. Okay? Any questions? All right, so this is a very nice equation once you embrace it and you see how useful it is to work out these situations where you have to get the initial value on the right-hand side. So with that, we close off the consumer arithmetic, or the main portions of consumer arithmetic, and we'll now start up with another topic, which is algebra. We're going to look at in depth into some algebra. We're going to write what algebra is. You could write it. Algebra is the representation. Algebra is the representation in symbolic form Algebra is the representation in symbolic form of meaningful results and patterns in mathematics. Simply put, it is where we use numbers, simply put, it is where we use letters. Simply put, it is where we use letters to represent numbers. Example. Write an example. If X represents the number of books, example, if X represents the number of books, and the cost of each of these books, is $5, the total cost of all the books are $5 multiplied by X. $5 multiplied by X, which would be equal to 5x dollars. Which is equal to 5x dollars. 5x is what we call an algebraic term. Algebraic. B-R-A-I-C. Five x is what we call an algebraic term. Okay? Next heading is addition and subtraction of algebraic terms. The next heading is addition and subtraction of algebraic terms. You write below that we can only subtract and add. Like algebraic terms. We can only subtract and add like algebraic terms. That is terms which have the same symbol. But may not have the same coefficients. That is, terms which have the same symbol but may not have the same coefficients. Before we elaborate on examples of these terms, what we should do is clarify how a number is made up. So if I write down this number here, 2x to the power of 5, like that. If I were to write that down, 2x to the power of 5, then what we will say is that the 2 is known as the coefficient. The 2 is known as the coefficient. Right? When you hear the term coefficient, it means a number in front of. When you hear coefficient, that's what it means. The x is known as the base, and the 5 is known as the power, or some people call it the index. Okay? So you could take that. Make sure you know when we talk about coefficient what it is. If you talk about the base, or if you talk about the power index in the context of an algebraic term, you know what it's all about. On the left hand side, we write down some examples of algebraic terms. Some examples. What are some examples of these algebraic terms? Well, 3x minus 4x and a half x. All these three here are like algebraic terms. All these three here are like algebraic terms because they are all terms in x. Another group might be 2x squared minus 5x squared, a half x squared. Okay, all those are examples of like algebraic terms. They are terms in x squared. The only thing that is really different are their coefficients. Okay, so these are like algebraic terms as well. And one more, 3ab, 5ab, and minus a quarter ab. All of these as well are like algebraic terms. They are terms in AB. Okay? Those are what we call algebraic terms. So after we have looked at the examples of algebraic terms, you write, right below that, the addition and subtraction of algebraic terms, the addition and subtraction of algebraic terms corresponds to the addition and subtraction of their coefficients. The addition and subtraction of their coefficients. Example 1. First example. If we had to add 15x plus 8x plus x. Then, in order to add that, all we have to do is to add up the coefficients, which we know is a number in front of the algebraic term, and then reattach back the algebraic term onto the answer. In other words, what we do, we add the 15, the 8, and the 1 there. 15 plus 8 plus 1, right? Because the coefficient in front of x is understood to be 1. If ever you're unsure and you think of point 0, ask yourself, how many x's are there on the board right in that position? There's only one x. So the coefficient there will be 1, and that's why you put 1 in there. And once you add up the coefficients, you just reattach the algebraic term that is associated with. So you would end up with an answer of 15 and 1 is 16 and 8 is 24x. Okay? So that's how you think about the addition of algebraic terms. What about a second example where you have more than one group of algebraic terms? For example, if I had 15x squared minus 7y squared plus 9y squared plus 8x squared. How would we treat with that? How do we treat with that? The first thing we'd have to do is to group like terms together. Then we combine the coefficients like we did in the first example, and we keep all the algebraic terms together. So if we look at combining all the x squared terms firstly, we'd end up with the 15x squared will be placed next to the 8x squared. Good? And then the minus 7y squared will be placed right next to the plus 9y squared. So now you notice that we have the like terms grouped together. All the x squared terms are together. Of course, keeping the signs in front of the coefficients. For example, plus 8x squared is kept with the plus in front of the 8. And minus 7y squared is kept with the minus 7y squared when you move it around. So then, after we group the like terms, the next step would be to add the coefficients and keep the common term. So it'd be 15 plus 8, and that will be an x squared term when we finish, and minus 7 plus 9, and when we through with that, we keep the y squared term, like this. So notice what happens here. 15 plus 8 gives us 23 x squared plus this plus sign, minus 7 plus 9 is 2. So that will be plus 2 y squared. So the answer is 23x squared plus 2y squared. Any questions? Okay, so you follow the procedure. The procedure is group like terms, combine coefficients, and keep algebraic terms together. Group like terms, which is what we did in the second part. We group the like terms here, and we group the like terms here. And after we group the like terms, we combine the coefficients here and here. And we kept the terms here and here. Okay, so we ended up with 23x squared plus 2y squared. Okay, the next thing we're looking at is multiplication and division of algebraic terms. Multiplication and division . and you write in, here all the coefficients are multiplied. Here all the coefficients are multiplied Here, all the coefficients are multiplied or divided by each other. Here, all the coefficients are multiplied or divided by each other. And the algebraic terms are also multiplied by each other. And the algebraic terms are also multiplied by each other. In the first example, we're looking on the board here at 3x multiplied by 5y. 3x multiplied by 5y. What do we do if we have to multiply 3x by 5y? Well, you just follow the rule that we studied there. It says the coefficients are multiplied or divided by each other, and the algebraic terms are also multiplied or divided by each other, whichever case you're looking at. So here, the 3 is going to be multiplied by the 5. The 3 is going to be multiplied by the 5, and the x is going to be multiplied by the y, like this. So your answer is going to end up being 3 by 5, 15. X multiplied by y is x, y. You can't do anything more combination of x and y. So it's just 15xy. Next example going up, minus 4 p squared q to the power of 3 multiplied by 3 p to the power of 3 q will be equal to, how we do that one now? Okay, we're going to be looking at something new here. In B, we know, just like in A, we have to multiply all of the coefficients and we have to multiply all of the terms themselves. So what we're going to be multiplying here is the minus 4 is going to be multiplied by the 3. You know that for sure. Then we also know that the p squared is going to be multiplied by the p cubed. And we also know that the q cube is going to be multiplied by the q. Good? Now q is the same thing as q to the power of 1. Right? If it's by itself, it means q to the power of 1. And what we're going to learn now are the rules when we have the same base in the algebraic term being multiplied with different powers or indices. Right? And the rule says that if we're multiplying the same bases but with different powers or indices, then we must add the indices together. Alright? So let's do this part. The minus 4 multiplied by 3, we know that is minus 12 because the signs are unlike. And what we're learning now is that because you have the same bases, you're multiplying them, what you do is you add the powers or indices together. The 2 and the 3 will be added. Then, on the other side, which is the q cubed by the q to the power of 1, that will be equivalent to q to the power of 3 plus 1. Right? Again, because the you have the same base, what you do is you add the powers. So this will end up to be minus 12 by p, which will be p to the power of 5 multiplied by q to the power of 3 plus 1, which is 4. Right? This multiply is not necessary. So it's really minus 12 p to the power of 5 q to the power of 4. Right? It's not required to put that multiply sign there. Okay, any questions there? So basically the law that we met here is that if you have a to the power, let's write it differently, m to the power of a multiplied by m to the power of b, then because these two are the same, is equivalent to m to the power of a plus b. That's what we just applied in this situation. Okay? That's what we just applied in this situation. Any questions there so far? No? Okay. Okay, so we're going to do our next example now, but this one will be with division in it. And this is a simple one. This one will be example C. And in this example, we have 12x divided by 15y. 12x divided by 15y. Very simple example. And we start off by saying that if they are dividing them, the coefficients have to be divided as shown, and the terms themselves, or the bases, have to be also divided. Okay? It's actually 12x divided by 15y. So I split it up here in advance, but this is really what it will look like. 12x over 15y. But then that could be further split up by looking at what could be divided here and here. We could say that this 12, what could go into 12 and what could go into 15? 3. 3 could go into 12 4 times. 3 could go into 15 5 times. Right? I'm going to leave this here, x, y. But then the reason why I'm showing it so wide apart is because I want you to realize that this could actually be split up into 4/5 and then x, y separately, like this. Or 4/5 x over y. Right? Sometimes they'd want you to break it up into that format. Okay, so that was fairly straightforward. That's C. That's C. And I'm going to do D right in that same space instead of rubbing it off. I'll do D right here. Let's do D here. And D was 12wx cube y cube divided by 36 w squared x squared y cubed. Okay? 12w x cubed y cubed divided by 36w squared x squared y cubed. Okay? How do we deal with that? How do we deal with that? Well, this is the same thing as writing 12w x cubed y cubed over 36w squared x squared y cubed, like that. Okay, the divide could be just the over sign. And how do we deal with these situations? Well, the first thing we could say is 12 could go into 12 one time, 12 could go into 36 3 times, like that. That's the first thing we'll say. Then, let us deal with the easy ones. Y cubed could go into y cubed one time, and y cubed could go into y cubed one time there, right? So they cancel out. But then we are looking at w over w squared and x cubed over x squared. So what I'm going to do, let's deal with each one separately first. X cubed over x squared is really x cubed divided by x squared. X cubed divided by x squared. And the rule for this situation where you have the same base, in this case you have x and x, that's the same base, being divided, but each of the bases have a different index, then the rule is you have to subtract the indices. So this would end up being x to the power of 3 minus 2. Just like when we are doing the multiplication, you have to add the indices when the bases are the same. When you're doing the division, you have to subtract the indices. So this becomes x to the power of 3 minus 2, which is 1. Good? 3 minus 2, which is 1. And x to the power of 1 is the same thing as x. Okay, so that is how we would deal with this cancellation here. In other words, the x squared would cancel into itself one time, and it would go into x cubed and leave x. Right? So that would cancel out and leave x right there. Okay? The last one we have to look at is the w and the w squared. Good? So what is happening here is, we're saying w into w is 1. W into w squared is what we're interested in. Right? So w squared is being divided by w, and I want to know what I should put here. That's my question, right? Because I say w into w1. When I divide w into w squared, what is happening? So w squared is being divided by w. That's what I'm doing here. So I want to know what to write here. But w is the same thing as w to the power of 1. So this would be equivalent to w to the power of 2 minus 1. 2 minus 1. Because again, you have the same bases in w. These are the same bases here. But they have different indices. One is 2 and the other one is 1. So what we'll do is, to work that out, you'll have to say w to the 2 minus 1. And w to the 2 minus 1 is the same thing as w to the 1. 2 minus 1 is 1, which is the same thing as w. So it means when I divide this w squared by w on top there, I will get w. Okay? So let's see what happens. When I multiply the top out, it will be 1 multiplied by 1 multiplied by 1. Sorry, 1 multiplied by 1 multiplied by x multiplied by 1. Okay? Because don't forget we have x here. When we cancel x squared into x squared 1, x squared into x cubed, we got x on top. So it will be 1 by 1 by x by 1. Let me write it back so you'll see it. 1 by 1 by x by 1 over what we have at the bottom, 3 by W by 1 by 1. Right? I just wrote back what we have on top there. So this would work out to be 1 by 1 is 1, by x is x, by 1 is x. So we get x on top over what we get below. 3 multiplied by W is 3W. 3W multiplied by 1 is 3W still. Multiplied by 1 is 3W still. So we get x over 3W. Now you could leave it like this, or some question might ask you to put it into a particular form. And that form may be where you have to have a fraction, right, as I'll show you now. X is the same thing as 1 times x, okay? And 3W is the same thing as 3 times W. So this answer here, even though it's perfectly correct, you may be asked to show that it is expressed in a different way. And one other way is, if we have 1 by x on top and 3 by W below, then this is the same thing as saying 1 over 3, which is a third, by x over W. So the answer could also be expressed as a third x over W. All right, so you learned quite a few things in that question there. But one of the main things you learned, I'll summarize it here as a law. One of the main things you learned there, I'll summarize it as a law here. Right, is that if you have m to the power of a divided by m to the power of b, right, that will be equal to m to the power of a minus b on top. Okay, that's one of the things you learned today. Okay, in summary, I'll give you 4 notes here that would summarize what we use here. You could write it quickly and then we close. It would summarize some of the rules that we learned here. The first one, which isn't actually here but you could use it, a law of indices is any number raised to the power of 0 is 1. Any number raised to the power of 0 is 1. Any number raised to the power of 0 is 1. Example, y to the power of 0 would be equal to 1. Any number raised to the power of 0 is 1. So if I write y to the power of 0, the answer is 1. Right? If I put 10 to the power of 0, the answer is 1. Any number you could think of. If I put 1600 to the power of 0, the answer is 1. Okay, so that's one law of indices that you learned there. Second law, or second item that we learned in these examples, any number raised to the power of 1 is itself. Any number raised to the power of 1 is itself. Any number raised to the power of 1 is itself. So if, for example, I had 10 to the power of 1, that is 10. If I had y to the power of 1, that is y. If I had x to the power of 1, that is x. So any number raised to the power of 1 is itself. The third item is when we multiply the same bases, we add the indices. When we multiply the same bases, we add the indices. Here, when we multiply the same bases, we add the indices. That's number 3. And number 4 is when we divide the same bases, Number 4 is when we divide the same bases. When we divide the same bases, we subtract the indices. When we divide the same bases, we subtract the indices, right? That is what we did in this example. Subtract the indices. Okay, so we'll close with that. I just have to get the homework for you now. The homework would be exercise 35 to 40. That would be exercises 35 to 40 and exercise 72. Right? And that would be in certificate maths. So into certificate maths, exercise 35 to 40 and exercise 72. Okay? Is there anything we did there that we didn't do in class? So what was so hard about it? Huh? Yeah. You understand? But the challenge here is if you see one question like that, you know, go ahead and look and see how you could do the others. But everything here is what we did before. Let me just run it back through again quickly. You start off with your compound interest formula, which is A is equal to P into 1 plus R over 100 to the power of N. This is your compound interest formula. Then you write down all the things you know. You knew that the principal was 250, that's what is being invested. The time for the investment, which is N or T, was 5 years. And the rate percent per annum was 8% per annum compound interest. So what we do is we substitute all these things into the equation for A. Right? We get 250 into open brackets 1 plus 8 over 100, all raised to the power of 5. That simplifies the 250 into 1 plus 0.08, which is really what you get when you work out 8 over 100, all raised to the power of 5. You go further down and you work out 1 plus 0.08, which gives you 1.08. And then that raised to the power of 5 is obtained by using the calculator. And in the calculator, you punch in 250 multiplied by 1.08, y to the power of x button, 5, press the equal button, and you're going to end up with your answer of 367.33. But we had said before that the amount accruing is the compound interest formula is A. And that is not interest. In this question, they ask you for the interest. So you have to recognize that amount accruing, which is the second equation that we learned, is equal to the principal plus the interest. So therefore, if we take the principal away from A, or A minus P, we'll get the interest that we're interested in, I. And that means that we'll take 367.33 and minus 250 from it, and we'll get the answer we're looking for the interest. So the interest I is equal to 117.33. The second question, the third question, the fourth question, the fifth question, all of them follow the same pattern. So once you could do number 1, you could do all of those thereafter because the same structure, right? The same structure. What was the next question that gave trouble for anybody? Anybody else on the side had any questions? Anything you want to get explained? Right, number 9. Which one? This?
Yes.
Oh, using the compound interest table, calculate the compound interest earned in each of the following. Right, so just like I instructed you on the simple interest table, you don't have to worry about the compound interest table. Okay? Is that any other question besides that one? Okay, even though I told you look at the questions in the exercise, those with the tables, it's not necessary that you learn how to do that. What other questions? Number? 18? All right, let me look at 18. 1-8. 18. A lorry costs 24,000 when new. 20% is written off its book value at the end of each year. Find its book value after 8 years. Good. Now, when we did compound interest, we didn't do the depreciation formula in that discussion. The depreciation formula would be slightly different from the compound interest formula. And the difference there is that you'd have a minus instead of a plus in the equation. So I'll write it out and show you what it means. What I mean by that. Okay. Now, in the depreciation formula, A would mean the value after a depreciation, which is called in accounting terms, the book value, right? The book value. And that be equal to the principal P, which refers to the initial value of the item in terms of depreciation. And here, it will be 1, instead of 1 plus, it will be 1 minus the rate of depreciation R over 100 to the power of N or T. Right? Let's put N for the number of years. Right? So in this case, A is what they're talking about, which is called the book value. This here is the initial value. Right? And this R is the rate of depreciation. Okay, that's the rate of depreciation. Now, practically, what that's about, if you buy a new vehicle, 1 year pass, can you sell the new vehicle back for the price that you bought it for? No, because it is assumed that there will be wear and tear on the vehicle price will drop. In accounting terms, that is known as the depreciation of the vehicle. So every year it would depreciate, value would go down. So what happens here now is we use this equation to find what the new value would be after it depreciates. And that value is called the book value. So you take the initial value, substitute it into this equation, and you would get what the book value is at any point in time. So that's what depreciation is about. It's very similar to the compound interest, except that instead of a plus sign here, because remember in compound interest, it keeps growing. It keeps growing. Anybody did the experiment with the 2 cents and plug it into the calculator and see what it came out to be? All right. When you get a chance to do it, you'll see what I'm talking about. If we're talking about depreciation, instead of it growing, it's actually going to keep depreciating. The value is going to keep going down further and further every year. So you use this equation. So in number 18, they say a lorry costs $24,000. It means then that the initial value or the purchase value of that lorry was $24,000. So that's what you're going to put here. 24,000. The rate that they say it's going to be depreciating at is 20% is written off its book value. That means the rate of depreciation is 20%. So that's 20 over 100. Right? 20 over 100. At the end of each year. Find the book value after 8 years. In other words, they want to know if this happened and depreciated where N was equal to 8. N was equal to 8. What would be the book value, which we call A, at the end of that 8 years? And you would just evaluate this here. So the book value A would be equal to 24,000, open brackets, 1 minus 20 over 100 is 0.2 to the power of 8. So that would work out to be 24,000. 1 minus 0.2 is 0.8 to the power of 8. All right? And by now we know how to punch that into the calculator. What we do is we put in, let me write it on the side just to remind you again. What would be the calculator? The calculator would have to punch in 24,000 multiplied by 0.8. Then you press in the button y to the power of x, because you want to take this 0.8 and you want to raise it to a power of 8. And when you do that, you press the equal sign and you would get the answer. Okay? And the answer you would get when you do that, anybody did it yet? You get 40,000, 24,000, right? Multiply by 0.8, you raise it to the power of 8. And you get how much? $4,026. $4,026.53, right? That is what your book value will be. In other words, this is the value that in the accounts of the company, right? If it was a vehicle in a company, that's what they would be valuing it at. That's what they expect to write it off as, right? The book, that's known as the book value. Just to elaborate on it a little bit, you know, the book value is not necessarily equal to the market value, right? Because in the books, if you use that strict depreciation technique, eventually your book value could be zero if you keep depreciating it right down. But you could actually go to the market and get it sold for a lot more than zero, right? That's the difference between accounts and the accounting and the actual market value. Okay? Any questions on that? Okay. Okay, so let me see.
What did I do wrong?
Okay. Now, what you did wrong, right? So I'm looking at the calculator here. It has 24,000 times 0.08, whereas you have to multiply by 0.8. Okay? So that is where you would get your error there. Okay, so be careful. Even when you're using your calculator, remember the calculator will give you out what you put in. So you have to be careful what you're putting in. Okay? Make sure you put in the right things. Any questions? All right. Anybody else had any other question they wanted to get solved? You good?